So when we have a circle, we know there are a few different parts of the circle that we can use to figure out the circumference, the area, things like that. Just to rewrite this for our notes, we did watch a video on this, but our radius is always going to be the distance from the center to the outer part of the circle, to the edge. And then the diameter is going to be any length that goes from the outside of the circle through the center and to the other side. So our radius and our diameter are right there. Some things we know are our diameter is going to be equal to the radius times 2, or 2 times the radius. So that basically means that the diameter is twice as long. And then we know the area of the circle. Our equation is pi times the radius squared, and our circumference is equal to 2 times pi times the radius. Or we can also write it as pi times the diameter, since we know that 2 times r is equal to d, like it says up here. So we can actually use either of those to find the circumference, depending on what you're given. So we know this, we can work through some of those questions, but just some examples from the 8.3.2 exercise so that we have some notes to refer back to. And so we have something to work with as we go through the practice that is assigned for today. Part A asks us to find the area of a circle with a radius of 10 units. So these equations will help us figure this out. As we know, the area is equal to pi times r squared. Since we know that our radius is equal to 10 units, then we know our area is going to be equal to pi times 10 squared. When we simplify that, we get pi times 100. So we can simplify this. Usually we want to put the pi at the end of the term. So we'll have our final answer be 100 pi units squared. Remember, we're talking about area. And if we were to write this in just decimal form, 100 times that 3.14 is going to be around 3.14 is equal to 314. So we could also write 314 units squared. Either of those answers will be acceptable, but technically the 100 pi units squared is more precise or accurate. Part B, so now we're looking for the circumference, and that equation is 2 times pi times r, but remember the 2 and the r means that it can also be written as pi times the diameter. So since we know the circumference of the circle is found using those values, we have our diameter right here. So our circumference is going to be equal to pi times our diameter of 7. So our final answer ends up being 7 pi units. This time we're talking about a one-dimensional measurement. It's just a length. And so for that reason, we're going to leave it in units, not units squared. And if we were to multiply that out to get a decimal answer, we would have about 7 times 3.14, which is equal to, we'll say 21.98. So we could also write it as 21.98 units. And just so that you have it up here, our value for pi is always equal to 3.14, and we'll actually put about 3.14 because the value for pi does go on infinitely. So that is our pi value. So that is our answer for part B, another way to find our circumference. These last two are a little different. We're going to be working backwards. So we're actually given the area and moving backwards to find our diameter. So for that reason, we'll write the area equation, which is pi times r squared. And since we can actually plug in 121 pi as our area, we're going to plug that in for the a value. So a, area, 121 pi, is equal to pi r squared. So now that we have this, we need to get r by itself. We want to find our radius. That's the one variable that we can locate. So we're actually going to simplify this by dividing both sides by pi, since there's a pi value on both, and those will actually cancel out. So we're left with 121 equals r squared. From here, we can take the square root of both values to get r squared to r, and we'll have 11 is equal to r. So our radius is equal to 11 units. But we are asked about the diameter. So we know that our diameter is going to be equal to 2 times the radius, which is equal to 2 times 11. So our diameter equals 22 units. So that's an example of working backwards to find our diameter. And I'll just label that here. And then the last one, our circumference is 20 pi, and we need to find its area. So we'll write down the circumference equation, which is 2 pi r. And we're actually given our circumference of 20 pi. So I'm going to plug that in for c. So 20 pi is equal to 2 pi r. I'll change that to blue now, so everything's blue. There's a couple things that we can simplify here. I'll actually do it at the same time. So we can factor out 2 pi on this side, and we can factor out 2 pi on this side. Nothing bigger, because the 2 on the right-hand side is the largest value that we can factor out. So that cancels out our 2's and our pi's here. It cancels these out, and then the 2 and the 20 become a 10 and a 1. So we're left with 10 on the left-hand side, and we're left with r on the right-hand side. So our radius is equal to 10. But we need to find the area. Again, area is equal to that's our circumference, pi r squared. So we know our area is going to be equal to pi times 10 squared, since we found our radius. So our area is going to be equal to 100 pi. Or, like in our first example, 314 units squared, since area is a two-dimensional measurement. So these are the two ways that you could answer that question. So there's some extra steps, but as you see, all of these started by using one of these three formulas and then using the knowledge of the value of pi being 3.14. And that is a little help for you to work through the problems of today's worksheet.